Cool. Well, hope you're well. Today we'll be playing Grid City.
Rob,
Yep.
I tried to download that branch and get onto it, but it won't let me. So
Okay, what was happening?
I don't know. Whenever I clone the repo,
Mm-hmm.
I don't get any other option but to be on the master branch.
Oh,
And I tried forking it too and download
sure. Okay,
and
let's have a look at
clone it, but it's probably just a problem I'm having because
it. Let's see. To be honest, I finished this game at 4 a.m. this morning, so it could be very well my fault. But main thing, if you see my screen now, so I'm switching to final game, and hopefully, if I download zip now, there might be a problem with the size of the file, but did you unzip? Did you get the zip or?
yeah, I zipped it.
And there's no code there, or?
It's 2 seconds. It's still downloading. It'll be another 40 seconds. My internet's pretty slow at the minute.
No problem. Well, that's. I think we'll have a kind of a bird's eye view over, like, kind of getting a game from A to B, and I'm probably going to give little bits of practical tips along the way. So practical examples. So I decided, okay, I didn't really have to do it, but I decided to get myself in your shoes and lead by example and basically make my own final game assignment take using the code that we've been working on. So in a few minutes you'll see how that works out. Okay, so let me just check. Yeah, I think no, all the code is there. That should be there. So, are you sure about the directories? Maybe something happened with your source.
Yeah, and I'll open it again and just check.
Yeah, it might take a few minutes to import. So, well,
That's grand. I'll check it.
I'll give everyone a few minutes to. How is the voice and video today?
Yeah, it's very clear.
Keep reminding me about the resolution, and in case I try to do the zoom. Anyway, so maybe while that's downloading, unpacking, and re-importing, I'll just have a quick playthrough. So this is Grid City, a procedural Pac-Man clone, basically using the little Grid City components that you're already familiar with. While the city is being built, I'm showing a title screen so that by the time the camera gets to the city, it's already built. So I'll show you how I achieved that. I have a little bit of UI with a title screen. It's all very kind of Psygnosis. I don't know if you were my age, you would kind of know that there was a kind of a cult game development company a long time ago for 8-bit machines and also the Amiga. And this is using the nav meshes baked that we worked on last week. Actually, the player controller is also using the same mechanism. That's what causing the movement to be just a little bit slidey at times, and maybe sometimes a little annoying, but on the other hand, it really cut down the development time because I didn't have to generate colliders for all those procedurally generated meshes. So this is kind of keeping it simple. So you can actually go through there. So I have points to collect. There's 361 points in this level. which is kind of doable, but and also there's baddies around. I don't see them at the moment. Ah, there's a baddie there on the horizon. So if the baddie sees you and is closer than a radius of 3, it will start chasing you. It runs slower than you, so you can outrun it. But if there's too many coming at you and you go into a dead end, then you might actually have a problem. So instead I'll press escape, and this will do an immediate suicide and game over, and I'll regenerate the level. Just trying to look for like a much smaller level. Maybe we'll have to cheat to get something that actually is winnable. But you know, if you've written the game, it's very easy to cheat in it. So press any key, and that's 260. That's still too large. So I'm gonna cheat, and I'm going to go into scripts.
Rob?
Yep.
I'm just pulling the origin for this project, and it's doing the fetching upstream, but it's only on like 5%, and it's taking a really long time. Would I be better off cloning it?
Yeah, I think maybe it's better just to download the zip, to be honest. But yeah, it's not gonna be terrible if you can't open it today, because I'll be kind of walking through all of it anyway. So maybe it's not too bad to just sit back and enjoy if you, because we won't be doing any live coding. This is basically the code as is, so I'll just be kind of explaining parts of it. So I think maybe for today, if you have a problem, then maybe kick back and just follow the stream as long as it's readable. But yeah, download the zip in the meantime, and maybe you can have a go during the break. Maybe you can play yourself and see what's going on. Okay, so I'm opening the root tile, which is at the moment I think our most complicated script, which is the one dependent responsible for creating the roads. So we already worked on that last week, and I've just added things that spawn things directly from the generated road. If you remember, in our recursive procedural building blocks, we had this variable max level or max recursion or whatever that just constrained how many recursions we're doing, how large we let the whole thing grow organically. And right now it's set to 100, so this creates quite large cities. Let me chop it down to 15. That's just one variable, and you'll see the whole game will be feeling completely different, and I'll actually be able to finish it. So let's see how it works with recursion set to maximum 10. A lot of things in the game. So right now the city is actually building in the background, but we're not showing it until it's ready, and then we do the camera zoom through it. So using an animation timeline like we did during our animation class, and now we're in the game, and we already have 36 points to collect. Unfortunately I have a baddie at my... oh no. Oh, there's a lot of baddies. Okay, so I have to... If the baddie doesn't see you, then it will not pursue you, but at the moment it's a little bit... I'm just gonna hide and wait for it to go away. So there's like a rudimentary AI in place. Okay, it's a little janky, but it proves the point that we can make a game really quick. Okay, I'm just gonna waste a bit of my life going through this area, but unfortunately I have 30. I have 6 points and very little health left. Oh no. Oh. Oh, I died. So basically all the assets in this are the ones we created during the course. There's some music I put in which is from a game I released 2 years ago, so feel free to recycle it in your project. Maybe if you want to release something with it, give me a shout. I'm gonna check with the musicians. They're not full tracks, they're just kind of musical stems which are only procedurally getting mixed. So every time you play, you actually get a little bit of different ambience in the game and also in the titles. So how it's done, we'll kind of get to all that. How is everybody with the project import? Do you need a few more minutes?
Just talking.
It's working now.
Cool stuff. Okay.
Uh,
Again, like if you're running it on a laptop and you're maybe it's a little bit too heavy, then that variable that I showed you there in root tile script max level, if you bring it down to something like 5, that will allow you to kind of like just test it without having a huge city generated. So I brought it down to 5, and another kind of a decision I made is that baddies don't get generated if they're too close to the player. So if the city is small enough, hopefully I won't have to deal with any baddies. Okay, it's a small city, no sign of baddies yet. Oh, there's one. But maybe I can handle this one. I still have some health. You can see I didn't make a huge effort at balancing this game, but there you go, I won. Whee! Wait till you have 1,000 points to collect, so that's when it gets challenging. I don't know who'd want to play that. Anyway. Okay, so like I said, this is a kind of a fully functioning game. It's quite limited. I went more for style over substance, so I wanted this to be like the Psygnosis titles, for example, so I used the font. So this company was quite famous for creating quite cool games like Shadow of the Beast, and this is a kind of a meme generator which just creates a random game box that looks like, I don't know, 1996 edition of Victim or whatever. Yeah. So I found the right font and I used the TextMesh Pro component here in our UI to create this title. TextMesh Pro is quite handy because it allows you to create gradients on the fly. I don't know if you played with it, but it's now part of, for a long while now, it's been part of Unity now. Okay. So how about I give you, well, I'll give you a kind of quick run around the big picture of the game loop and what's what, and then we'll take a break. You have a chance to maybe play it for 10-15 minutes, and then we'll have a kind of an ask me anything type session, and I can, because there's definitely like maybe too much to even contain in 4 hours. I will do my best, but it will be more useful for you if you focus on the bits that are pertinent to your own game project. So, to begin with, what's in this scene? This is a single scene game. There's nothing else, it's just this grid city scene. So obviously we have some very minimal setup of a skybox, a few lights, our floor, the same stuff you're already very familiar with. Here is a control element. So this game object control is what I use to kind of organize. Windows magnifier just Windows magnifier crashed on me. How great. Sorry, can you still hear me?
Yeah.
Okay.
Everything seems unchanged at our end. We can still see the.
It's. I'm just not sure. I think it just had a little bit of a hiccup when I tried to zoom in and out. Okay. So, in the scene, the control object here has a grid city manager, which is the city manager that we've always worked with for building city. A new element called the game controller, which is where most of our game loop is, and game flow. And audio master, which is like a kind of audio manager that controls the music and the special effects. Other than that, there isn't that much in the scene to begin with. Everything else is spawned at runtime. There is the UI canvas, so all the let me do this at runtime because otherwise I'll mess up the whole game. So we have our game title, a press key thing with a little bit of a flashing fade done with coroutines. So kind of a feature overview. Game over screen is just a separate object that we enable or disable when we need to. And congrass, basically simple text elements. Now game overlay here is a canvas group holding more UI elements. Familiar with canvas groups? They're very handy for fading between different groups of elements together. So this canvas group here has alpha, the opacity 0, and if I bring it to 1, my whole game in-game overlay shows up. So in a coroutine, somewhere in the game controller, you can imagine that when we go from the title screen to the game mode, there's a transition which takes this canvas group and brings its opacity to 0, while at the same time bringing the opacity of the game overlay to 1. So this is exactly what's happening now. On a curve, no less. There's a little fade curve which we can author. We can change it to a different curve and try it. Actually, let's try it now. I'm just going to press escape. This kills the player. Waits 10 seconds. And then what it does is there's a little trick involved. It just reloads the scene. We don't worry about reinitializing everything, making sure our flags are cleared, because that's like the number one place where you'd get bugs and problems. So how about I go into the game controller, pick some really weird curve for transition, and press any key now. So this is how it went. I actually have a chance of winning this game because there's only 12 points to collect. By the way, the controls are WASD and the arrow keys for rotation. It's kind of very, very simple, all of it. Okay, one more point somewhere left. Will I get it? Yeah. I should disable the baddies if you win. Okay. I should give them a death animation or something. Okay. So you see that value of 5, the recursion is a little bit that's a little bit limited. Let's bring it back to 75 or 100. This will give us the full glory of procedural city. This is the root style script. Again, this zooming doesn't really like me. So in root tile, max level. Oh god. Not sure why it's misbehaving like this, but now I'm stuck on 125%. Come on. Anyway, while I wait for my computer to refresh, so there's actually quite a lot of new code in this, and I don't expect you to dive in and understand all of it, or or use all of it, but as you set up your own minigame, if you run into some problems, I think it's easier to have code that's actually working to have as a reference. So that's what I was trying to do with this. Okay. So let's go to 100 max level. So game controller, did I change something here? Don't know. I had 2 copies of Visual Studio open, that's probably not healthy. That's 100, so that's okay. Great. So at full capacity, you can see here in the scene view that city takes a while to build. That's not a huge level, that's okay. Sometimes even with a large recursion value, you end up with a small enough city. Let's start it, and also, as you know, every time it will look a little bit different. There's some sound effects that you can't hear right now. I'm not gonna experiment with the sound setup now because of the recording. So there's 73 points here that need to be collected, so this will take a while. I'll just hide from the baddie. Oh no, I can't. I'll run away and try to hide from him. Okay, maybe here they won't see me. They're actually patrolling on their own random tracks, so even hiding here I'm not entirely safe. One thing that I added to this version of the city generator is grid view. So this is, you press G key and you can actually see all the through the environment and see all the city array elements that have been populated. So this helped me greatly in debugging, and actually you can use it in scene mode as well if you choose to use this. So I'm gonna go to the scene. Here in the layers drop down, if you select grid view, then you'll be viewing that layer as well. So this way you can actually see what the code is doing with your city. I had a couple of bugs. Let me actually show you. So I started with a situation where the city was building okay, the road was building okay, but I knew that something was off, that sometimes it conflicted with some buildings. So by adding this additional visualization element, which is just those cubes, which don't do anything in the game, they don't have colliders, they don't interact with anything, they're not used for raycasts, So they just exist there solely for debugging. And it shows me that, oh, okay, I probably filled the city array incorrectly here. And this might cause problems later on. For example, if I have another building that wants to build here, and the city grid array will allow it, because from this standpoint of the city array, this is a free space. So it would totally mess up our route. And also, this is an example of that large structure that I created last week for you. And you can see that there's a mismatch between the city grid representation and something that we placed manually in the scene, because it's rounded to the integer and kind of doesn't exactly correspond to the blocks. But as long as it's kind of close enough, then it's not a big problem. This was a bit of offending code which I had to change to get the city generation to update the city array properly. So this now tells me these cells of the array have the right value of true. Any questions about the grid view? Let me show you really quickly where that happens. It's just a line of code.
Sorry, Rob.
Yeah.
Rob, just a quick question out of curiosity while you have it on screen. What are the cones that are above the grids representing?
Sure. They represent targets. So because we're using nav meshes and we want the baddies to be kind of moving from one place to another, what I've done is just create a bunch of targets and randomly assign them to the baddies. This causes like say this baddie to go from one target to another.
So they're effectively waypoints, is it?
They're effectively waypoints, and just kind of like a very minimal version of patrol routes. So there's a coroutine on each baddie that randomizes a time for patrol, gets a target from a list, because these targets are generated by the tiles as well. Everything that's like a game object in this is actually spawned from a tile, because that's our kind of like a game floor, right? This is the active object. And what's more, it's only spawned from tiles which are flat. In this case, yeah. I don't want things spawned on the stairs because of different weird effects I might have with the navmesh agents and so on. Here the baddies seem to be like blocking each other, so I'm not sure. Maybe they're seeing me but trying to get to me. Not sure. Well, anyway, there's definitely a lot of room to tweak it. Here the navmesh didn't get generated properly. That's what was happening. They did see me, they tried to get me, but the navmesh wasn't correct. I'll pause and I'll go to navmesh surface and let's see what exactly happened there. Yeah, so this navmesh totally didn't get baked. Okay, unfortunately. So in some cases this procedural system just kind of fails. Too bad. Maybe this can be fixed with slightly different settings. I don't think there's anything particularly wrong with the meshes that we've generated. It's just for some reason it decided to do this totally corrupt nav mesh. Fortunately, this happens like most of the time. It actually acts quite okay. Let's see now. So nav mesh surface. I'll disable the grid view. And let's have a little fly through, see what's happened. Most of the time the nav mesh seems to be happy, especially for small ones. There are some areas where the nav mesh cuts through the geometry. Well, what this will result in the game is that obviously the player will kind of, and the baddies will kind of seem to sink in the floor for a small time. So if you're looking for more polish, that would be one area which definitely needs a bit more love. Okay, 32 points, so I'll be able to win this one. One thing you can notice here that there are some buildings inside the tower building, so we didn't actually fill this grid city fully now as we place our monolithical tower. We are able to actually go underneath the roof of the temple or whatever it is. That's kind of a, I think that was a nice addition that gave the thing a chance to breathe. Okay, now a few baddies appeared, but I'm almost there with the points, so just run them out. Actually, I think there's a little bit of challenge in this little game. So, okay, so big picture. We have a couple of game states, and after we win the game or lose the game, we just reload the level. So that's the kind of like that's all in a summed up in a sentence. But let's get into the game controller and have a look closely what's happening there. So game controller script. I've set up an enumeration called game state. So there's a couple of game states basically: title, prompt, game, game over, and congrats. So that's a kind of like just a very general state machine where we want to kind of manage which game state our game is in. That will help us for all the other objects, which can suddenly, you know, they can ask, okay, if I'm in game mode, then I can keep spawning baddies, or if I'm in game over state, then I stop chasing the player, and so on. Okay, getting occasional pickups again. Sorry for that. Okay, so we have a private variable game state, and we have actually a property game state. This is an interesting bit of code here. So this is the getter and setter for the property game state. It's using our private variable game state as it's kind of hidden, inaccessible, basis. But what's important here is that this is public, so this can be used by other objects to set the state of the game if needed. And what's happening is if, like for example here, if previous state is not equal to game state, so if we're trying to set the game to a value that's to a state that it hasn't been already, then we check which state are we trying to enter. And for example, if we enter the title, then we reset the game. Now what's happening here? Originally the game state, the original value of the game state, the default value is title. So this is what the game comes preloaded with. When you start the level, we are already in title. So even if we set this property to title, if we set game state to title, because the previous state was already title, we don't reset anything. We just carry on with as usual. On the other hand, if we were in a game over state or congrats state and we enter title, then we do a reset game. And what does reset game do? That's a worthwhile kind of exercise to kind of go through, go to implementation, and just basically see what the flow is. How does this code walk through the whole game state? Because this is a simple setup, but it'll be fairly similar in like a larger game as well. So reset game here takes the current scene, gets the current scene from the scene manager. So scene, so it's variable scene of type scene. We get active scene from the scene manager. To use scene manager, you have to include Unity Engine scene management. Okay, and once we have the scene, we load it again. We load scene with this name. And that's it. That resets the game and makes everything kind of safe. Okay, what next happens with our game controller? Well, start method is doing two things here. First of all, it initializes the random seed. So I don't know if you know, but any random number generators, they're not actually random. They're all kind of random looking number generators, which are deterministic. So unless we do something special initially, which to initialize the random number generated with some kind of a value that's not the same every time you start the program, then we'll end up with the same set of levels every once in a while, every time. So in here I'm just using something which is time related to initialize the state of the randomizer. And the next thing that happens is we start a coroutine which is called game loop. And this coroutine, and I'll explain why I went with the coroutine, is where most of the magic happens. So if you look at the game controller, like in most of our scripts that we've been creating so far, the execution was running in the update method. Whereas here in game controller we have something happening in the update method, but most of it has to do with inputs. So every frame we do check for whether escape code was pressed or G key was pressed. This was the one that changes the view from grid mode to other set presets, or with any key down is pressed. Again, if the game state is game, then we check if escape has been pressed, then we go into game over immediately. If we press G, then we change the culling layer mask for the camera. There's an array of culling layers, masks. Let me show. So I've showed you how this camera can toggle between different modes. All that's happening there is actually quite simple. There is okay, so this is the setting for a camera where you select which layers are being shown, right? And this property or this field is called culling mask. But in our game manager, game controller, sorry, we have a layer mask array that I've set up and I've initialized from inspector, which has size of 3, and it has 3 selections of masks. So in one mask I show everything except from the grid view, from the yellow blocks. In another I show everything, and yet another I show only the grid view, the player, and a couple of other things, enemies. So now it becomes very easy to toggle, because what happens is if we press the G key, so which layer mask, so this is the index, and we kind of want to take the length of this array that you just saw, the array containing 3 different masks. We increment the current index of the mask, but we want to go from 0, 1, 2 back to 0. So that's why we use mod. So layer mask length is 3, so if we have 3 here and mod it with 3, we're gonna get 0. So this is like the remainder from a division. This will make sure that we never use an array index that's not within this range of 0 to 3. So here, main camera culling mask is taken from the array using this index which layer mask. So these 2 lines of code are actually toggling the culling mask. This kind of trick is used a lot as well in different cases. Like I don't know, maybe some of you have already used this type of structure before. However, in this game, especially that I've kind of like insisted on doing things procedurally, there will be lots of arrays which hold elements, and then we randomize an index. So get familiar with this kind of approach. I'm sure you'll be using it in future. Okay. So let's have another quite quick look at what's happening. So first we have the title screen with no prompt, and we need to make sure that everything is built, which takes a while. The buildings get built and need a little time. The roads need building. The nav mesh needs to be baked. But because of this cinematic camera path which hides all this, then when we arrive we see the whole city. So this is kind of like a little bit of smoke and mirrors to hide what we don't want to show. How this camera transition is done is very simple, and I've went through it over at the during the animation lecture. Basically, you always have to have a playable director element, assign a timeline to it, and have some kind of a transition there. What it means also that we need to switch the camera between cinematic controlled and a player based cam, so there needs to be some code somewhere that goes between those modes. Okay. Now we've entered the game mode. We have 784 blocks to collect, so I don't think I'll be finishing it anytime soon this year. The nice thing is that the baddies are few far in between, so we don't have to worry about it. We can stroll. You can see that as I pick up the points, the score overlay obviously is incrementing. What else happened? Obviously the points were spawned on flat tiles, and then there's a baddie. Okay, so how did this all come to be? Well, remember that in the start method of the game controller, we've started this coroutine called game loop. Remember coroutines? Nice handy function that allows to stop it and pause it and wait until the game does other things in the meantime. It makes a lot of sense to have the game loop there because it allows you to kind of like wait, have little stop and pause checkpoints. Let's have a look at that game loop coroutine. This is it. So actually this is the whole game kind of contained there. Not a lot really. Let's zoom in. I tried to leave some comments in there just to make things a little bit more palatable, but again, if you have other ways of setting things up, or don't use coroutines, or don't need a game loop for your project, it's okay. I'm not forcing you to go to elaborate steps like this, but most games would need some kind of form of state management. So this is an example. I hope it helps you somewhere down the line, maybe. So first we initialize the randomizer. Again, I think I'm doing it twice, so it's not necessary. And then we reset some variables just to make sure that there's 0. This is also not necessary because the level is reloaded, but just in case in editor something happens not the way we expected, I just reset the maximum loot and player loot. Maximum loot is the amount of points in the level. This obviously only gets incremented as points get started and spawned. Now player loot in the beginning is 0, that's our score. Baddies registered, there's a flag that just tells us how many baddies are in the level. Patrol locations is a list. So here patrol locations is, we'd like to have a dynamic list of locations, which are basically transforms, for the navmesh agents of the baddies to pick and match from. So that we go send the baddie one way, and then after some period of time we send it to the other way. And this kind of, pretends that it's having a mind of its own. So let me go back to this game loop. So what's happening now? We set navmesh ready flag to false just to make sure that nobody uses the navmesh because it hasn't been generated yet. We reset the audio manager, audio master, so we kind of like make sure everything sounds are stopped. and then we play the title music, so there's a dramatic intro music, and play the cinematic timeline, which is the camera movement. So all that is kind of happening instantaneously, it just gets started, and then we start randomizing the level. So what we normally did in City Manager class, now we're doing in the game loop here. So we randomize stage, which is basically selecting a random sky color and things like that. Randomize tower flavors, which means there's a bigger library of building profiles and we pick only a few for our given city, just to make things different between each playthrough. So, you know, have a closer look if you need it. If not, it's just a kind of a nice touch. And here comes the benefit of the coroutine, which is that we can do a yield return new, wait for seconds 2, which means we can just wait for 2 seconds now. And the rest of the game is executing. Why do we think we need to do this here? Because we've done some randomized stage, some operations which maybe take more than 1 frame. So I'd like to make sure that this is already, actually in this case, those 2 seconds are because I've placed some things in the scene that, like the monolith, the big temple needs to be drawn first. So this is really extreme. It's probably like 10 milliseconds would be enough for this, but just to be, you know, make a point, we just wait for a little bit. Now we use a build towers method, which is basically just one step up from what we've been doing so far. Sorry, I just went into the... Sorry, back. Build towers. I'd like to go to the implementation of this. So this is part of this is part of the City Manager class. So build towers basically lets you provide a number of towers, and it builds them. It just builds it places the building prefab at the root of the tower and lets everything else happen after that. Additional here, I'm checking that we're not taking up the center of the game field, because if we did that, then we probably will prevent the whole road thing to be from generating. I keep center between -5 and 5 on X and Z. We keep clear, and this will allow the routes to get started basically. So that's all that happens there. That should be clear. It's just a parametric version of what we've done always in with building our towers. We're not we're just calling it from a different place here. So I'm building the towers with a random number. So every game it's going to be a random number between 25 and 45 towers placed in the scene. Because those towers take a little time to build, I'm calling another wait for seconds, yield return new. After that, we do build roads. So we place our route tile somewhere in the scene at start location and let the whole thing also build itself. And we give it 3 seconds. In the meantime, remember that we've already started the cinematic timeline, so that's happening independently of this code flow, and the camera keeps going down as we go through these things. So this is a kind of a handy trick. After that, we bake our navigation mesh, so that also takes a little while. I think there's a little bit of a stutter, and when that happens, you will notice that. But we'll give that 3 seconds as well. After that, we set the nav mesh ready flag to City Manager to allow. Not sure this is so very necessary at this stage, but anyway. What this means, the intention is that right now the navigation mesh is ready and we can start placing objects which use it. Because as you remember, if you place an agent, a navmesh agent, and the mesh isn't, and the navmesh isn't there, you'll start getting errors and all kinds of problems. Okay, so we've gone that far. So now we go into different game state, the game state prompt. And remember that transition to that state caused the menu to change. This happened in the getter and setter of this, the setter of this variable. So if game state, if we assign this prompt, game state prompt value to game state, what code gets executed? Well, the game state setter. Let me find it. See, this is where the game state is declared, and this is the setter for it. So we set it to a value, and now this value is the switch statement here. This is the switch, which basically conditional branching statement. So if this value is equal to prompt now, game state prompt, we go into the prompt game state, we just show the press key object. Object. So this is the little dialog with the flashing prompt, and that's it.
Sorry, Rob.
Yep.
Does switch in that case mean that it only executes this whenever there's a change in value?
Well, look here. We have a previous state. So we have a local variable called previous state, and we just take the existing state of the variable. This happens before the value is assigned. So anywhere in the game, if I do game state equals whatever state I want, this code gets executed. This is the get and set. So this is a handy way to have some control over what happens when you change this game state variable. You can have a lot of the game loop in here as well if you want it, like, you know. Yeah, here if I'm checking that the previous state is different from the changed value, because here the value tells me this is what the game state has been set to. So value is the value that, like in this case, game state prompt is the new value. So I'm assigning it to the game state private variable, and now I'm checking if it changed. If it didn't change, I don't look at any of this. There's no point. We didn't change state, so nothing happens. However, if it did change, and we're in prompt now, then we run this code. So this switch value, Yep.
Sorry, Rob. Just another one there. I'm saying you're declaring previous state is equal to underscore game state.
Yep.
Just before that if statement. Would that not mean that previous state will always be equal to game state?
No, because you see, this game state hasn't been changed. That's very good. Good question, and I think it's a good point too. I'll get to this. So right now,
just the way
this is where the magic happens. This is the one line that triggers all this mess. So take a close look what's happening here. We have a game state without underscore. This is the property. This is the property. Yeah. And this is, okay, this looks funny because it's an enumerator. So it has to be in the game state namespace. But basically this could be any value. Like if I made the enumerator so it's like human readable, but this could be integers. This could be 0, 1, whatever. So this is the value we're assigning to it. This is the value. And this is the property. And now if you look at the setter of this property, this is what defines what's happening when we assign the value to this property. So when we get, when something is calling about what the value of game state, this code is called. It can also do something in print statements or whatever. If we set the value, then imagine this is a private underlying private variable. This hasn't been changed yet. We haven't touched it. We have to touch it here in. We have to change it here in the setter. So first we take the previous value of this private variable. This is not identical. This is the property, and this is a private variable that's kind of wrapped with this property.
So when underscore game state has been returned by the get function, that's not actually overwriting the previous value of underscore game state at that point in time?
Get is just getter, so it just returns a value. So this is if I print game state somewhere, if I have a statement like somewhere in code, if I have debug log game state, if I do something like this getter will be executed to give me this value. It will put whatever we put here. I can put 2 and it will always print 2, whatever. So you kind of you have full control over what's happening during an assignment and a check value kind of like statement with property.
Yeah.
We can no, it's very good.
No, I'm just not fully understanding. The way I see it there is that you get the underscore game state and then you're setting
get defines get doesn't get executed now, because this get defines what happens if this property is accessed.
Okay.
So if somewhere in the game, so this actually didn't get executed right now, because the only thing that's happening now is we're doing this. This is a set operation because we assign this value to this property. So when you assign a value to a property, the getter is ignored.
Okay, so when you're assigning, it jumps to the set as opposed
it
to
just
running get and then the set.
Yeah, this isn't run as such. This is like kind of like defining what's happening when you get that variable, and this defines. Yeah, I didn't get over it before. Maybe I did earlier on when I did the instancing and the singleton, but it was kind of like fairly early on. So maybe everybody was just.
So when you declare a game state variable, it executes whatever is in the set segment there, and it ignores the get segments.
Yeah, if you assign a value to the game state property.
Yeah.
Just to be clear about the language, because that's kind of like we have three things. We have the private variable, which is kind of like hidden from. That's the purpose of a property. It kind of encapsulates a private variable. So there's something that the other parts of the game don't need to know. It's just like your local variable that's hidden from everyone else. And what's exposed and what's public is this game state variable without underscore.
Okay. So if I understand correctly here, say I created another game state property, let's say call it my game state, and I said that was equal to game state. What would happen there is it would run the get component
on the get game state,
yeah,
and then the setter on this new one.
Yeah, and then but if it was say changing the value of game state, it would do the set section.
No, it isn't checking whether it's changing or not. Like the setter is done always when you assign the value. It doesn't know whether it's changes or not. It's here.
No, that's what I mean. Is that it's just whenever I say that game state is equal to something, it'll do the set.
Yeah.
Apart. Okay. Yeah. I understand what's going on.
Yeah, that's all there is to it. Yeah, it's just it's just how it's set up with getters and setters. So C#, script reference, get set statements. It's a whole kind of. It's not maybe kind of crucial, fundamental coding that you necessarily need to use. You don't have to use it at all, but you'll see it a lot in code because it's. Programmers like to use their fancy ways of, and it does have some uses in this case. Like it allows you to kind of make sure if I change the game state to some value, I'll maybe change something in the UI. That's one way of using it. And about that, because that's two things. There's the getter and setter, and then there's the switch statement, right? So we probably didn't dwell a lot about the switch statement either, but maybe this is a good time now to go through it. So basically what happens in a switch statement is that you switch on a value, so you switch on a variable, and if that variable matches any of these cases, then the codes in the corresponding case clause get executed. So first what I did in my setter is there's a nice minus expand collapse thing here, so you can actually make code more readable for yourself. So if you want to make have a kind of bird's eye view, first collapse everything and let's see. So the getter just gets me the value of game state, private variable, so we know now that this is the one with the underscore, and the setter does something if previous state, if the game state changed. And what does it do if the game state changed? Well, first it prints that we're entering a new state to the debug log console, and then it switches on the new value. So I could just as well, I could have switched on game state, yeah, because that's already been assigned there. But anyway, let's leave it as it is. The keyword here is, and the key, the keyword is value. Is that get, set, and value are just parts of this getter-setter structure. So this value is going to be whatever we assigned to our game state property. You see it's even highlighted in blue, so it's kind of like a special keyword. So this game state here, the private variable is now assigned the new value, and if the value changed, then we do stuff. Okay, so by now I think it should be kind of clearer. And now let's focus on the switch statement. We take the value and we know that we have been in a different state and now we're entering prompt state. So we entered, we showed the prompt on the UI, and that's it. Okay, so let me move on. It's a kind of I know it's a kind of a quick safari through the whole thing, but I don't want to leave you kind of without any kind of guidance through it in case you want to use parts of it. Okay, where were we? We were here. So now what's happening in our game loop coroutine is that we can just sit and wait. So while the state remains prompt, we just let yield execution. We don't do anything. So this loop will keep going forever until the state changes from prompt. And we know that the only way we can change from prompt to game state is when in the update, here we switch on the game state, and let's say our game state is prompt right now, so we're sitting and waiting in this prompt state, and every frame we're going to be checking this. So either if we press escape, then we go to title, so we restart the game, or if we press G, then we change the view, so we can do that in the main menu. We can change to see the grids, or if none of these is true, we can also check if any key has been pressed, and then we go into game. So this is what actually starts the game here, this one key press, which you get most likely from this. Okay, so that's kind of how it goes. If it helps, maybe draw a little diagram for yourself. I'll see, maybe I'll make a little schematic to make it a bit more easy to navigate through. But this is, it's still fairly simple setup. I tried to keep it minimal, but obviously trying to make the game to work, I had to add components and flags and stuff just to make sure that everything behaves more or less okay. And that's what you'll be doing with your assignment as well. Oh, by the way, I wanted to check something. The next week, is it reading week for you or not? Because you didn't have one the last time. Week 6, you were there. So I'm not sure if officially that was, I think there was only 2 people in class. That was before COVID. I'll verify it, but I'm not 100% sure if we have a lecture next week or this the last lecture.
I think some of the other modules have finished up, but
Yeah.
I think that's just because they've nothing really left.
Sure. Well, I mean, if you have lots of exams to prepare for, then definitely reading week. What I'll talk to you about is what we're going to do with this. Let's call lab test 2. I want you to look at it more like as a creative coding exercise too, just more relevant to our city building exercise. So what's probably going to happen is you're going to get just a bit more time, and it's going to be like a partial assignment for the final project or the final project. We can, if you want to meet me next week, if you want to do some kind of like live coding session, I'm happy to do it for you. So you know, it's I'll verify what's the official story like, because most of class, this was when the epidemic started and the lockdown started, so it was a bit of a, I think like a lost day anyway for most of you. So we'll see. Well, look at it like this. You know, if I can give you some assistance with it, then you know, use me and ask me questions. So, so let's continue. We are entering the game, so we have to start doing a couple of things. We spawn the player, so we instantiate the player prefab that I created. We set the player health to maximum. Player body is a transform that actually points to where the player is in the scene. There's a distinction because I had to do something funny with the player because I'm using nav meshes. So I actually have like a two-body player. One is a nav agent and one is something that just decides the direction you're pointing at. It's maybe a little clunky, but it allowed me to avoid using extra colliders in the scene just for a character controller, because otherwise people would be falling off those roads. So instead I made a nav mesh agent which actually drives the movement, and only I don't use its rotation. So I have like two objects. Let me just jump into that. I'll show you the player prefab briefly. So let's find the prefabs, player, and let's drop it in the middle of the scene here. So what's there? Not much. The main weird thing is that this player object is actually always going to stay in the center of the scene. This is not going to move at all. It does have a script which controls things, and it has a reference to the player agent, player nav agent, and also the player figure animator, and also camera transform for the camera and target for the camera, and some other small things. But the main thing is that we have player figure, which is the animated character. If I disable that, we won't see anything. But also we have the nav agent, which is the nav mesh agent, the humanoid, which traverses the nav mesh. So the combination of these two, as controlled by this script called character. I should have called it player. I called it character. And this is all that it is. Most of it comes from what we've already done for the character controller during animation lecture. I just expanded it to have some additional states, like dying and winning. We randomized the reaction of the player to win and lose states by using just a simple random range. We have a little coroutine for hurting, which I think actually I possibly broke because I didn't see that actually working. What's important here is here on trigger enter. So if we hit a collider of the enemy, we start the hurt coroutine. But I think if I deleted all this, then there would be no difference in the game, because it's the baddie that takes our points away. So let me delete this prefab now. Let's have a quick look at the baddie. Baddie is a simpler object. but much similar. So I still have all the animator components, which are, there's a whole skeleton structure which allows the animation to happen, but we don't worry about this. We have the cube renderer. Remember the cube, because I started with a cube in Blender and I just sculpted the character by extruding bits of a cube. That's why I forgot to rename it. That's why the player, this little fella is, the mesh is called cube. Meanwhile, in the baddie script, we have a navmesh agent and a collider and an audio source. What does the baddie script do then? Okay, there is a little bit of logic in there. There is a coroutine, which is unassisted baddie. When nothing else is happening, it will just randomly pick a patrol time, 5 seconds to 30 seconds, get a random target from the game controller, so request a patrol target. Where should I go, mommy? And then if target is not null, it will just run the nav agent to that destination using all the path traversal. So this is how the baddie suddenly starts running in a certain direction. It looks like it's trying to do something, and then we wait in this coroutine. So coroutines are handy for things like this. However, here we have a onTriggerEnter event being called. So if other tag is equal player, then game controller instance hurt player. So we take the instance of the game controller. We don't need to hold it in a separate variable. We can just always access it through its public property instance, public static property instance. Again, that's a kind of a throwback to the very beginning. I was telling you about statics. Is that still sounding kind of threatening, the static thing, and calling the instance through a? Because you see, this game controller is actually the name of the class. It's not a variable, because this instance is a static field. Does it ring anywhere familiar? Because we can spend a few minutes on that. It's worthwhile, because if not, I'll just move along.
When you say instance here, is that
that's
where's that game controller instance located? Is that on the player or on the
game controller? Is the only, there's only one game controller to rule them all. So this was kind of like let's go to the game controller just for a second. It's this script that we've this class that we've been talking about through all the time before we switched over to baddie. And let's have a look.
Would you run into problems then if there was more than one instance of a game controller in the scene? Or
yeah.
would you just pick the first?
It will pick one of them or whatever, but in this case, yeah. I didn't do any special checks because there's only one in the scene anyway. What's kind of important, but I think in different point in the lecture I did give you an implementation of where if there is already one, it will delete this one. Yeah. You can find examples anywhere also. It's like this basic singleton. It's the singleton structure. Singleton. Yeah. So in this case, there's another property. So again, there's a getter for it. Why is there only a getter? Because we never assigned this instance. We don't give it an option even to assign. We can query it. So by calling this static, this keyword static, makes it tied not to a particular instance of the game controller, but instead it's held with the class itself. So there's only one instance. So this, in a way, like this variable, there's only one. It's static. And you access it not by an instance of the game controller. Normally you'd have, like, say, let me show you. You see Grid City Manager class. Here we have a variable which holds a reference to the city manager. Right? So that's an instance. of that class.
Yeah.
There's an actual object that's been generated. Meanwhile, here, this instance comes with a class. You don't actually need, there doesn't need to be an instance anywhere. You'll be able to call it anyway. So when we go back to our baddie, I don't need to have a game controller variable. I can just call just directly access the static field of the game controller class. It's a kind of a, I know it's a bit abstract distinction, but again, you'll run into it. So it's like better, better early than late. So in this case, all I could have done is let's see. I could have created a variable and assigned it in the inspector to the game controller. Right? I could have done that. And then I could have done game controller hurt player. This is calling an error because blah blah blah, but actually this would have had to be somewhere else, obviously. But you get the idea.
So this is say more streamlined because we only have one instance.
Well, this is more because we want to avoid assigning everything by hand in the inspector.
Okay.
You see, you kind of either we'd have to do it in a wake function or whatever, by not having this variable to assign to, and instead just asking for that instance from the class itself for the instance. It kind of made it a bit safer and easier because everybody that gets created can immediately access the game controller because it's public and it's also static. So I don't need a reference, I don't need to worry about the inspector, I just ask for what's the instance of the game controller. We know that in kind of like in between the lines we know this is probably a singleton, so we ask for an instance of it and we call this function hurt player. So the instance of the game controller which is in the scene is here in the game controller class. What it will do is if the game state is equal game and if damage timer is bigger than damage interval because that's incremented every frame, then we reduce the player health. This was to stop from different frame rates having different results on health. Because if you do something every frame, for example, it would mean that your health would just disappear on a fast machine immediately when the baddie touches you. So instead, I have a little interval. I decrement the health by 1, and then 0 the timer, and the timer has to increment again until it reaches damage interval, and then we can hurt the player again. So it's a kind of a suppression system.
Okay.
Right.
Thank you.
So, as you get kind of more comfortable with these things, you'll be just kind of like, okay, this is what I do here, and it kind of comes from muscle memory. You set up this kind of timer thing. Everybody has their own kind of. So the more you do it, the more you use it, the quicker you'll get in the end. So okay, so go back to game controllers. This was the baddie logic, more or less. It does a raycast. So what's happening here actually? There's a lot of connections between those modules. I think this would call for some kind of diagram. Okay, here's a game controller, here's a audio controller, he's a baddie, here's a player, and they communicate this in that way. In practice, I just say, okay, I need this, and only game controller has it, so I use an instance. In this case, I need the position of the player body. And remember, it's not the player prefab position because that's always static actually because I'm not moving it because we have two different independent things moving with the player, the nav mesh and the actual displayed player. That's maybe overcomplicating a bit, but it actually made the implementation a bit simpler. So here in update frame, the baddie actually raycasts. I have another timers here so that this raycasting doesn't happen every frame. I don't really necessarily need to do it, so I do it every half a second. I take a aim vector between the eye of the baddie and the player, and then I raycast from the eye transform to the player. There's a max range which is defined at 3 units, so I'm not gonna find the player if it's further out than that range. And there's a raycast mask which allows me to specify exactly which layers I'm casting for. So if there's a building in between me and the baddie, this will block it. And if there's a player in this mask, then it will give me a hit if there's a direct path from the player to the baddie. And if the hit collider attack is equal player, then we set our nav agent destination to the player position and the baddie is suddenly chasing us. And we also set a funny sound to play. And we zero the timer, so that's it. Again, similar, you see similar patterns coming back, so maybe that's because just I don't know how to do it better, but it works. So in the other case, if we do a raycast and the collider is not player, then we just request a patrol target. And actually, this was something I've implemented quite quick, but I see a limitation to it. This actually will affect the... this is actually very bad. So I'd like to have some kind of additional variable which will tell me whether I've been on my normal patrol route or not. So I'm gonna do that now, and we should be able to fix this bug that I just realized. I didn't actually realize. So public bool regular patrol equals true. Okay. So if we are regular patrolling, so if the baddie is on a regular patrol, then we start chasing the player and we set regular patrol to false. Okay. However, if the hit collider tag is not equal to player, I want to prevent from changing the target of the baddie if we're not chasing the player, basically. So so if we don't hit the player collider and we're on regular, we're not in regular patrol, so we have been chasing the player, but now we run a raycast and we don't see the player anymore, then we request another new patrol target from the game manager. And if we don't hit the player and we're on a regular patrol, then we don't do anything. So that's it. That's all I wanted to fix in this. Because you can see what it was causing the baddies to behave erratic, because every half a second it would have just gotten picked another location, and none of this would matter anymore because these times are supposed to be
What kind of variable was regular patrol again? What did you declare it as?
Boolean.
A Boolean.
So
okay.
regular patrol is normally, and it just gets changed to false if we see the player, and if it's not a regular patrol, so if we're chasing the player, then we get request a new target, point the nav mesh to the destination, and also we go back onto regular patrol. So here we change it. I think actually that's see how nice it's to talk through one's code. I wish I had that kind of luxury all the time. Let's try. Let's see if it improved it. Make sure if you're testing out prefabs, as I'm doing, don't forget to delete them from scene after, because that might mess everything up. So let's have a closer look at the baddies now. City's building. We're kind of due a break for a little bit, so we can make a longer one and you have a chance to play it yourself. Cool, alright, so let's see. Let's watch the baddies. Oh, this one is already attacking me, the bastard. I made the AI too good. Oh no, okay, just hide. Okay, that's good. And let's just look at the scene and see what they're doing. Let's just sneak there and see. You see there's a baddie that's moving somewhere. One is stuck, you know. This one is... But anyway, they don't seem to be doing anything super erratic. Oh, this one has found me. Oh. So you know, it's only a couple of lines of code, and it actually does some kind of a workable mechanism. So if you think it through, okay, it's actually quite fun to play with it. Hiding. So any minute the baddie will see us and it's within the right distance from us, it will start running. Maybe to make it more visible, I'm going to switch the layers in the scene view to nothing and only to enemy and grid view. No, grid view is not a good idea. So let's see. This guy is not doing much. Maybe it's already found its target, and let's check. Yeah, it's actually waiting at the target. So after a certain timeout, it will pick a different timer and move somewhere else. So you can play around with all kinds of different mechanics for baddie. Traversal and AI. Okay, so let's hit pause on the recording there for a while and